Good morning po, ma'am. Pwede mag-start sa ta or magkuhan na ta, ma'am. Magulat sa ta nila.
Start na ta.
Ma'am, okay po, ma'am. So, before we start, let us have our prayer first. So, may I call somebody to lead our prayer this morning? So, Angela Jana Lumawan, please lead our prayer this morning. Angela Lumawan, Lumawan, can you please lead our prayer this morning? So I think Ma'am Angel, so Angel Lumawan is not having a trouble with her uh, internet connection. So may I call Ariel Dominding to lead our prayer this morning. Ariel Dominding. So can you hear me, class? Anyone who can? Nadungog ra ko, class?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, so that's good. So may I call somebody to lead our prayer because somebody kanina si Koan, si Jumel si Valios. Kindly please read our prayer this morning. Hello, class. Can you hear me?
Yes,
Only
sir.
here, sir.
Wala lagi magkuano. So, kanina lang si Salatan Dandy. Can you please lead our prayer this morning? Hello, Salatan.
Okay, good morning, everyone. So let's tampo tas.
Sige, you may now start. I think Mr. Salatan has been out with our room. So Miss Emma na lang, Emma the hero to lead our prayer this morning.
Okay, good morning, everyone, especially to you, sir, ma'am. Okay, let us, for those Catholic, know, let's sign of the cross. Okay, thank you, Father God, sa kinitanan, Lord, akong interest di kanimo, Lord, especially, Lord, as we go through to our lesson today, nga akong ipangayoon di kanimo, Father God, nga diin sa among lesson nga pag ah sigutan karon, Lord, nga masulod sa among tagsa-tagsa kaw na una, Father God. Kining tanan, Lord, akong gisalig o gipasalamatan sa kanimo. Kining tanan akong gisalamatan na gisalig sa imong ngalan. In Jesus' name we pray. Amen.
Okay, so amen. So good morning, class.
Morning.
Morning.
Good morning.
Sir.
So your attendance will check when you enter this room. So we have our automated attendance checker in this Google Meet class. So before we start, let us know first our virtual class rules. So first, we have mute yourself except when you have the floor. So if you have queries, please unmute your mic if you want to talk. And then use the virtual hand raise if you want to talk. Third, avoid unnecessary action or sound. Fourth, encourage everyone to participate and respond appropriately. And lastly, be attentive and prepared. So is that clear, class?
Yes,
Yes,
sir.
sir.
So in every activity, I will give you corresponding points for you have to gain points in this class session. So before we start our class discussion, let us have review on your last topic that you have discussed with Ma'am Humarito. So can you remember your last topic? Can you still remember your last topic?
Yes, sir.
So what is it?
Acid base equilibria. Equilibria.
What is an acid? Can you define what is an acid?
Acid, sir,
Well,
is based on my own opinion lang. It's a liquid that can cause or when mixed to other substance can cause reaction which is kanang if kusog ang acid makakause siya mag-melt ang usa ka particular nga butang.
okay, thank you for that. So Nahian will get corresponding points for that. So anyone who can define what is a base? A base.
A baser is a molecule or a liquid uh, that is a proton acceptor and also a electron donator.
Okay, thank you for that. So this time, I have an activity that I want to share with you. So are you familiar with the game Four Picks One Word?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's
Sure.
good to hear. So very good. So now I want you to gaze the hidden word that the picture has been described. Is that clear, class?
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
kinsa tong mauna nga maka-answer is hatagan na
Acid.
siya
Acid.
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 kinsa man to sila si Koan si kinsa tong naka-answer si yes that's
Nahiyan, sir.
Sinahiyan. Okay. So number 2.
Base.
Ano
Base.
Yes, it is a base. Number 3 for the what is it?
Taste.
Base.
Okay, very good. It is a taste. Next, we have this one.
Smell.
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 Okay, very good na yan. So, it is smell. Next, this
Ta
one.
touch?
Touch.
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 Is it touch?
Touch.
Touch? No. Wait
Touch.
ah.
Sound.
No, no. Kapit na.
Tactile.
It starts with letter T.
Texture.
Touch?
It's
Texture.
texture. Yes, it's texture. That's correct. So, Kyle will have our points. Next, what is it?
Color.
Okay, very
Color.
good. So, yes, it is color.
Color.
Color. So, this time, please keep all those words for just because we will use it in our discussion. So let's enumerate it first before we proceed to our next activity. So first we have the acid. Next, we have the base. Next is the taste. Fourth is the smell. Fifth, texture. And lastly is the color. So you make a good jump up to our discussion. Now that you have that word, what I want now is to use that word through relating it to our next activity. Is that clear, class? So this activity is just simple. All you need to do is to guess whether the object that is being described is an acid or a base. In answering this activity, you just relate your observation on our first activity. Is that clear, class?
Yes, sir.
Yes, sir.
Okay, very good. You're right. So what the first picture is this one? Is it an acid
Acid.
or base?
Acid.
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 Acid. Acid, sir.
Okay,
An
very good.
acid.
Kabalo naman mo, no? So, it is a acid. So, what property of a citrus fruits does considered to be an acid? So, unsay na
Citric acid. Ay, citric
Citric.
acid.
okay, very good. So, citric acid has the property or the oranges, uh, for example, has an citric acid in its properties, which make them acidic home product. So, next, this one class. Is it an acid or a base?
Base.
A
Base.
base.
Base. Base. Base.
Okay, you're correct. So this is a toothpaste and it is a base. So toothpaste is a bathroom staple in homes. It is a base substance. Sometimes toothpaste are ideal for temporary relief for skin burn. So our next is this one, carbonated beverage. Is it an acid or a base?
Acid,
Acid.
sir.
Acid.
Acid.
Okay, you're right. So it is an acid. So carbonated beverage or sodas are acids because they contain carbonic acid. So while these carbonated beverages are safe for consumption, they can cause corrosion in metals and other materials. The next is this one, baking soda. Is it an acid or a base?
Base.
Base.
Acid. Base.
Base.
I
A
base.
base. It's a base.
Okay, you're right. So it is a base because so unsay may property sa baking soda nga na belong siya or natawag siya nga base. Unsa may
Sodium
naa niya?
chloride.
So you have a point. So sodium
Chloride.
bicarbonate. It's sodium bicarbonate. So it is an example of a base. So baking soda is a weak base used for human consumption. So people use it in cooking, baking, and cleaning. So people sometimes use baking soda in sprays for ironing to keep clothes crisp and firm. So another picture is this one. What is it? Is it a base or an acid?
Base.
Believe
Base.
it.
Base.
It's a base. So you're right, you're correct. So home cleaning powders are bases and cannot be consumed. And in food preparation, because of their strong nature, they have effect on metals and other surfaces. Examples of base cleaning powders include detergent, bleaches, bathroom cleaners, and other bleaches. So this time, so let us have this ammonia, our last picture. It is a base and
Base.
acid.
Base.
Base. Base.
So yes, that's right. Ammonia is a man
Base.
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 Yes, it is a base. So ammonia is a colorless gas in room temperature. So when manufactured in liquid form as ammonium hydroxide, it becomes a household product with a variety of uses. So most people prefer it as a cleaning and disinfectant solution for various surfaces and fixtures. So since ammonium hydroxide is not harmful to the human skin, it also functions as an insect bite solution. So this time class, I want you to share your learning and observation based on the activity that you have done a while ago. I will call somebody to share its learning and observation. So first, sinahiyang kay murag daghan-daghan siya na kuan na 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 observe og na kuha nga correct nga answer. So Nahiyang, can you please tell us your learning or observation based on the activity that we have?
What I've learned are just a simple or a small observation about our activities a while ago is that there are different types of acids and we can find it in this world like citric acid that is found on fruits like oranges, lemons, and other citrus fruits. Now, when we talk about base, it talks our my observation is that bases are more on commonly they are used as cleaning agents like those bleaches and other unsa to katong mga ammonia. That's also
Okay, that's correct. So very good, Nahiyang. Thank you for your valuable observation that you have shared to us. This time, I will pick another students to share the observation and the activity that we have. So may I call Kyle to share its learning and observation?
So, what I have learned is, sir, that an acid is uh, for me, base at sir. Ang base is something uh, is more commonly found in cleaning, like Nahian said, a base is commonly found in cleaning agents like
Yes, that's correct.
bleaches or mga sabon ng ana din. Ang acid is more like something in it's more like something that corrodes metals or something. More as
Okay, that's correct. You're very good. So, give yourself a virtual clap kay daghang gyud mo na learn og na observe sa karon nga sa kaninga activity. Na nagid mo yung mga learnings nga na learn throughout sa inyong discussion kay Ma'am Humarito. So this time class, can you guess what will be our topic this morning? Anyone? Who can guess our topic this morning? Based on the activity that we have.
acid and base, I think.
So you have a point. So topic na. So our topic this morning is all about the properties of acid and base. So this morning, before we start uh, discussing our topic this morning, let us know first our objectives. So at the end of the lesson, the students can first differentiate the properties of acid and base. Second, demonstrate the properties of acid and bases using hydrochloric acid and sodium hydroxide and their reaction with litmus solution, the blue and red, the zinc metal, and solid sodium carbonate. And lastly, recognize the presence of acid and bases to the food that we eat in our daily life. So is our objectives attainable, class?
Yes, sir.
Yes,
Yes,
sir.
Okay,
sir.
it is unattainable if we have cooperation and participation in this class. So, so our so before before we start our discussion, let us uh, please open your naka-download na ba mo akong gisend sa GC ay Google Classroom katong laboratory worksheet na naman
Wala
naka.
pa, sir.
Wala pa, sir.
Okay, so kay wala no pwede ko ninyo i-download karon kung makuha ninyo ma-download ninyo kay ato atong gamiton karon. So using this laboratory experiment, I will discuss to you some important sign or properties that acid and bases have. We will see how certain substances react to other substances. So please open and get a copy of the laboratory worksheet that being posted in our Google Classroom. So, so first is I will show to you the reaction or determine the reaction of litmus solution in an acid and base. So, wala tong sa nato class kaya medyo nag-loading. So here it is, class. So first we have our sample 1 and we will see what will happen when this sample this first sample react to the litmus solution. So first we will get a drop of this sample and then we will drop it to our litmus solution, which is the red and blue. So we will see what we will what will be happen to this to the color of this litmus solution. So observe mo, class, ha. So class, what have you observed? The color sa litmus solution. Naunsa siya. What happened to the color? Is it and then it is an acid or a base? So may I call Emma for to share its observation to our sample 1. Uy, wala.
Excuse me, sir. Nag-share screen ka?
Wala nag-move, sir.
Wala nag-move, sir.
Ay, so, wala siya nag-move. Hindi ay na so, stop sa kong share screen. Wait lang mo, class, ha. Kana, okay, ta na?
Yes, sir.
Sige, thank you. So, our first activity is we will determine the reaction of the litmus solution to our sample. So we have 7 sample here, and we will see what we will happen to the color of the litmus solution. So first we have the sample 1. So I will get a drop of this sample and then drop it to our litmus solution. Observe mo class ha, sa unsay may tabo sa color sa litmus solution. So kani class, so what have you observed?
Na-change
The
ang color.
Change ang color.
Change ang color sa litmus solution. So from blue
Red.
red.
to red.
So, now,
Red.
can you guess it is an acid or a base?
Acid, sir.
Acid.
An acid.
Acid, sir.
Okay, that's correct. So it is an acid. So ngano man unsay naa sa koan?
Acid.
Yes, that's correct. It is an acid. So we have our sample 2. You will see what we will happen to the color of the litmus solution. So what happened, class? Sa color sa
It
The red the
It
red
turns out
litmus
blue.
solution turns into blue.
Blue color.
So it is an acid or a base?
Base, sir, base.
Base, sir.
Sir.
So it is a base. So the given sample is a base that turns red litmus solution to blue, but that does not affect the blue litmus solution. It has a pH value greater than 7. So maya-maya i-explain ako sa inyo ha kung isanin ko ang pH value. So, doon sa nato ni tanang samples. We have the sample 3. So, same ra siya sa sample 2. So, ang koan, the red litmus solution become blue. So, it is a isa mang class. Base. So, the given sample is base. That turns red litmus solution to blue. So, by the way, class, this litmus solution is used to test the pH balance of the liquid or substances. So, most substances are either alkaline or the base or an acid. It is a solution of different dyes extracted from a liquid plant. So we have our sample 4. So, sa may nahitabo class. So, same ra siya sa sample 2 and 3. So, it is a base. We have our sample 5. Okay, so unsa may na-observe ninyo?
Same gyapon.
Same like hapon.
Same.
So let us have the sample 6. So kani class, nag-change po siya, no? So unsa may na-observe din yon?
Acid, sir.
Acid,
Nag-turn
ang
siya into
blue
red.
makuan na turn into red.
Okay, that's correct. So ang litmus solution from blue nahimo siyang red.
Red.
So it is an acid. So the given sample is an acid that turns blue litmus solution to red, but does not affect the red litmus solution. So our first test tube didn't change its color. So next, our last sample. So same ra siya sa kuan class no. So, sa sample 6. So alkali or basic or basic chemicals include baking soda, ammonia, and lye. Uh, an acidic substance include vinegar, lemon juice, and battery acids have a property to change the color blue litmus solution to red. So bases change the color of red litmus to blue. So when blue litmus solution is placed in a substance that is acidic, it will turn to red as what this experiment determine. So kung acid siya, ang blue litmus solution mahimo siyang red. Tapos kung base siya, ang red mahimo siyang blue. So however, if placed in a substance that is basic or neutral, it will remain blue. So blue litmus paper is meant or blue litmus solution is meant to test only for acidic pH level. So when red litmus paper is placed into a basic substance, it will turn to blue. So if it comes in contact with an acidic or not a neutral substance, it will remain red. So red litmus solution is meant to test only for basic pH level. So according to Arrhenius concept of base acid and base, hydrochloric acid is an acid that turns blue litmus solution to red. So if napata sa kuan kana face to face nga kuan, kung ato daw ni siya, kung hydrochloric acid ni siya, ang atong kuan, ang atong sample, pareha ra gyapon siya result. So ang red, our first test tube, the red litmus one will remain its color. But sa blue, mahimo daw siyang red. So sodium hydroxide is a strong base. Its pH is higher than 7. So it turns red litmus solution to blue. So is that clear, class? Nakasabot ra mo say kuan sa ato ang first experiment, the reaction of the litmus solution.
Yes, sir.
Yes, sir.
Okay, that's good to hear. So with that, so we will proceed to our next experiment, which is the reaction of zinc metal for acid and base. First, we will pour a drop of our sample to the test tube and see what will happen. Observe mo, class, ha? So next, ang nato ato ang cork, and then open nato ato ang Bunsen burner and see what will happen. So kana, class, what did you observe? So inyo na observe sa fire sa kuan.
Napalong.
Napalong siya. So let's have our sample 1. Balikan na to. O diba? Yung observe, diba napalong ang kuan,
Matchstick.
ang fire sa matchstick. Tapos non sa man ang fire, diba? Non sa fire. What have you observed sa fire sa kuan, matchstick? Diba namatay, tapos masyab ni
Explode.
no? Masyab ni dako. Another. So, di ba? As you as you observe, the fire dips out with a mild explosion. So when metal reacts with an acid, it generally displaces hydrogen from the acid. So it is acid siya. So the given sample is an acid that reacts with zinc metal to liberate colorless, odorless, and hydrogen that causes the flame to flare up. The flame then dips out with a mild explosion and popping sound. So this leads to the evolution of hydrogen gas. So kani di ay, as you can observe na say murag bubble-bubble. So kani bubble-bubble murag nag-evaporate ang hydrogen gas padulong diri. Tapos pagkuan sa matchstick with flame, napalong niya ang matchstick tapos nag-explode ang with a mild explosion ang kuan, ang fire. So, for example, the reaction of sulfuric acid and with zinc. So, when dissolved in water, acid tastes acidic and conduct electricity and react with metals to create hydrogen gas. So, that's the reaction of the zinc metal to our sample, to our heat sample. So, our sample is just the same. So, according to Arrhenius, concept of base, acid and base say that hydrochloric acid reacts with zinc metal to form zinc chloride and hydrogen gas. So as you can observe, mani ang giingon oh. Mo tay nagpa mild explosion sa fire ang hydrogen gas. So now class, did you understand the process why such reaction has been occurred? Kung sa may inyong na-observe, can you have can you share to us your observation and learnings to this experiment, the reaction of the zinc metal? So may I call the baby Jane Aso. Baby Jane Aso. Wala, no? Wala siya ba iyang signal. So sinahiyan na lang kayo. Siya may participative kaayo. So I will give points for those students nga mo answer sa ato ang mga questions. Sinahiyan, sa may na-observe nimo?
So, ang the gas nga kanang nainitan sa Bunsen burner evolved into a hydrogen gas which burns and causes a mild explosion on the matchstick.
Okay, that's correct. So when our sample heated and react with the zinc metal, it causes to have an evaporation. So ang iyang pagawas kay hydrogen gas which makes our fire have a mild explosion on it. So this time we will see how solid sodium carbonate reacts with our acid and base through the phenolphthalein and other samples. So let us have our last experiment. So first we have here the phenolphthalein and our sample. So first we will add a sample, we'll drop a sample to our solid sodium carbonate. So muna ito ang solid sodium carbonate o kanina sa test tube. Tapos we'll add our next sample. So what happened, class? Is it an acid or a base?
Acid, sir.
Acid, sir.
Acid.
So it dili siya acid,
It's a base.
it's a base. So
Base.
the given sample and sodium carbonate are bases. So they don't react, but from an alkali solution, phenolphthalein produces a pink color in alkaline sodium. So our next sample sample 1. Asisin ba siya? Sample 2. Okay. We have here the sample 1. So we will have a drop of it to our sodium carbonate and a distilled water. So observe class what will happen to the lime water. So as you can observe,
Evaporate, sir.
nag-evaporate siya, no? Nasa murag mga bubbles. Tapos what happened to the color of the lime water?
May change sa color
Mga
niya, sir.
gatas.
Mura na
Nasa
siya.
nahimong
Nag-white.
gatas, no? Nasa nahimong white. So as you can see, the gas bubbles, magnesia, are evolved from plus and turns the lime water to milky. So the gas produced is a carbon dioxide due to the action of the sample of sodium carbonate which turn lime water to milky. So as you can observe mo din, kaning mga bubbles, mo niya ito ang carbon dioxide. So, nagkuhan siya, na-transfer siya into our lime water which react and then turns into a milky color. So next sample. Kani, di ba? As you can observe, ang kuan from sample 1, ang atuang sodium carbonate nag-react siya sa phenolphthalein nga solution. And then nag-turn siya into unsa nga color?
Pink.
Pink color.
Yes, it's a pink color. So when phenolphthalein and the other sample was added, there is a reaction where the sodium carbonate become pink color. So sodium carbonate are alkali. So they do not react but form alkaline solution or the base solution. So phenolphthalein gives pink color in an alkaline medium which is the pink color. So this time class, let's have some short discussion on the properties of acid and base that found in our food and things that we eat in our daily life. So nakasabot ra mo ani class? So first,
Yes, sir.
maglipot ta. So sa litmus solution, if it is acid, what happened to the litmus solution? From blue?
The blue litmus solution turns into
The
red.
turns into red.
So sa base pod,
Opposite.
The
The red.
red's litmus solution
Turns
turns
to
into blue.
yes, correct. So sa zinc metal, naunsa siya? What have you observed?
The gas will evolve into a hydrogen gas which will cause a mild explosion on the matchstick.
Okay, very good nahiya. So nahiya, very participative kayo, no? So, kaning uban, aha naman ning uban, di na lagi sila maningog. Napa ba ni or nagkuan ra? Nagpin ra sa to a meeting. So our direct class sa sodium carbonate, what happened? If we add our sample and the phenolphthalein, what happened to the color of the sodium carbonate?
It will turn into pink.
Pink, sir.
Turn into pink.
They don't
Yes, mo siya, pink. Yes, sa to.
they don't react but form an alkaline solution, sir.
Yes, correct. So katong kuan po kani siya non sa ang color sa lime water.
May milky
color.
ang
Mga
niyang
gatas.
color.
Hindi na siya may
All white.
Ano siya? Milky color. So what acid or compounds produced by this reaction? Sa kanimo nagbabol-babong sa ganito siya nga kuan, compounds or
Carbon dioxide.
sodium bicarbonate.
No, din.
with carbon dioxide. So so carbon dioxide mo tayo nagpa-change sa color sa atuang lime water. So is this experiment understandable na class?
Yes, sir.
Yes, sir.
So let us have our short discussion on the other properties of sa class mag-share screen sa to. Let's go back to our Wala pa mo kakita sa PPT class?
Wala po, sir.
Wala, sir.
Okay, sige. Wait lang mo class ha, kay ni class. Kita na?
Yes,
Yes,
sir.
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 Yes, sir.
Wait lang, wala siya na play, no? Play.
Wala.
Yan. So this time class, nakita na ninyo ang PPT? PowerPoint class? Anyone who can respond?
Wala gyapon, sir.
Wala,
Ako
sir.
naman siguro ng ano, ang
Kana na class?
sir, sir.
Ay, mo na na.
Okay, thank you, no? So let's proceed forward to discuss.
Nakita na, sir. Nakita na.
Okay, sige, thank you, thank you. So now, this time, we'll have a short discussion on the properties of acid and base that are found in our food and things that we eat or use in our daily life. So first, what you so what have you seen now, class? How can you relate it to our topic, the properties of acid and base? First, we have the bubbles and the lemon. So may I call someone to share it? So si Ayana James Sujon. Can you tell us what have you seen now and how can you relate it to our topic? Ayana Jane. So may I call na somebody si Krisa Aran sa ni pagbasa iyang koan? Si Krisa.
Sir?
Krisa. So how can you relate this picture to our topic? So what have you seen now?
A lemon and a drop of water.
So, yeah, so it's a bubble. So how can you relate it to our topic?
So, lemon is an acid po. Tapos,
Ang
it
bubble,
is related part because lemon is an acid. Then bubble is
yes, that's correct. So another property of the acid and base is the taste and texture. So if you were to compare the taste of an acidic solution to a basic one, which is not advisable if the pH is very high or very low. So you would find that an acidic solution taste sour. So, for example, sour, katong kuan, lemon, no? So, unsa may taste sa lemon, di ba? Sour siya. So, it is acidic. So, well, basic, one taste bitter. Bitter. So, the sour taste in citrus fruits is due to the citric acid they contain. Vinegar is sour because it contains acetic acid and the sour milk is high in lactic acid. Alkalizing mineral water, on the other hand, has a mild but noticeable bitter taste. So another defining features between the acid and base is the taste and texture. It must be noted you should always follow lab safety guidelines and never consume or directly touch chemicals. So, nakasulod na ba mo kuan? Laboratory?
Yes, sir.
Yes, sir. So, most of us is nakasulod na, no? So, di ba ang first guidelines yun kung ang doon sa laboratory is dita mo taste o texture. So, dapat mo follow yun tag guidelines. So, before this regulation were set in stone to protect us, chemists used to taste chemicals. So, in fact, most famous physicists and mathematician Sir Isaac Newton tasted over 100 different chemicals when he practiced alchemy. So among these was the element mercury, so which is a highly toxic and has been attributed to his death. As previously mentioned, acidic solution have a high concentration of hydrogen ion. So this makes acid taste tart or sour. So through this, you should never consume any acid in the lab. You can relate this to test of a lemon, which is acidic. So next property is the pH level and pH level of acid and bases. So the pH scale is a measure of how acidic or basic a solution it is, and it ranges from 0, as you can see class, from 0 to 14. Acidic solution have a pH of less than 7, whereas bases have a pH higher than 7. So solution with a pH of 7, which water or the H2O are considered to be neutral. So as you can see, the pH scale is a measure of how acidic or basic a solution it is. The solution with a pH of 7, such as water, are considered neutral. There are many different ways to measure the pH solution, but two common methods that are used is the indicator and the probes. So, in calculating the pH scale or the level of the acidic of the bases, we will use this formula. So, pH is equal to negative log times the positive hydrogen with a positive ion. So, na may calculator guys, class. So,
Sir.
sige, so please calculate. Let's assume that the concentration of hydrogen ion is equal to the 0.001 mole per liter. So, calculate daw ninyo if correct ba ang 4. Calculate the pH using by the pH to hydrogen with a positive ion formula. Sige daw class. So unsa may result?
4 ang answer.
Okay, so 4. So aha man nabutang ang 4. Is it an acid or a base?
An acid.
Acid.
So it is
Acid, sir.
an acid. So our sample is an acid. So naa siya sa 4. So kung from 6.9 going to 1, it is an acid. So
Acid.
lapas po siya 7. 7.1 to 14, it is a base solution. So another features or properties of acid and base is the reactivity of acid and bases. So makarelate naman ta ani katungkuan sa zinc metal ug katuyang reaction. First, we have the reaction with metals. So when acid react with metals, the outcome is very similar to the neutralization reaction. The only difference is instead of producing water, we'll get hydrogen gas. So when acid reacts with metals, the outcome is very similar to the neutralization reaction. So regardless of what acid or metal is used, it will always produce salt and hydrogen gas. One of these example is the reaction between the magnesium and an hydrochloric acid. So when combined, the resulting product are magnesium, chloride, and hydrogen gas. The next is the reaction with carbonate. So acids can also react with carbonates, in which case produce salt, water, and carbon dioxide. So acid can also react with carbonates, in which case produce salt, water, and carbon dioxide. Carbonates are formed when combined with metals and organic compounds. The unique features of this production of carbon dioxide and the hydrogen gas. So, for example, sa katuwa-tuwang experiment ganina, so unsa may yang nakuha na produce katong sa reaction of the zinc metal. So ganito yan na produce class. What happened to the color? Yan.
Green.
X nahimo siya sa zinc metal. Ang kuan
Pink.
na-produce siya carbon dioxide, di ba? Sa zinc metal. Tapos katong
Yes.
na-produce ang carbon dioxide which makes the flame explode mildly. Tapos sa katong isa, katong sa solid sodium carbonate, when we add the sample and the phenolphthalein, nahimo siyang color pink, di ba?
Pink.
Tapos
sir.
katong isa sa lime water, na-produce po siya isa nga gas.
Carbon dioxide.
Hydrogen gas. It's hydrogen gas.
Hydrogen gas.
It's hydrogen gas. So, naunsa ang color sa koan sa lime water? Nahimo
Milk.
siya.
Milk.
Anong gatas?
Okay, nahimo siya ang gatas. So now you have already know the important properties of acid and base. I want you to answer or recognize some home products that we use or whether it is an acid or a base. So this is just a sort of review for our evaluation this morning. Also, you need to give the reason why you see it so, and you will type your answer on our chat box. Is that clear, class? So na ako ipakita
Yes,
ng mga picture. So mo niya ito ang summary sa itong answer. Sa taste na siya sour, sa basis na po siya bitter. So first picture. This one, vinegar. Is it an acid or a base? Simple na kayo.
Acid, sir.
Why okay? Ito na asa, vinegar. Ito na asa vinegar. What acid? It's
Acetic.
acetic acid. So vinegar is a popular home staple. So people use it at home for cooking, and it is ideal for cleaning agent because of its acidic nature. So next, we have this one, soap. Is it an acid or a base?
Base.
Base.
Okay, you're right. So soap has a slippery texture and also an example of a strong base used for bathing and cleaning. Next one, yogurt class. Is it an acid or a base?
Acid.
Acid.
Acid, sir.
Acid. So yes, it is an acid. So
Acid.
yogurt is made by adding a starter or bacterial culture to pasteurize, homogenize warm milk. So in this warm temperature, the bacteria convert lactose, the main sugar is a dairy products, into lactic acid. So this makes it acidic with a potential of hydrogen pH ranging from 4 to 5. So next is apple. Is it a base or an acid? Apple class. This is
Acid.
Acid, sir.
Acid.
Acid.
Acid, sir.
Acid.
Lagi.
acid.
Acid, sir.
Final. So you're right. So apples have a pH of 4, which falls in the acidic range. Therefore, apples are acidic with an ascorbic acid that are commonly known as the vitamin C. So it is another type of acid that found in apples, which is significant amounts in which has a significant amount. So as with malic acid, with apples have more ascorbic acid than farm apples. The next one, class. Kani batteries. Is it an acid or a base?
A base.
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 Why did you say so? Anong base man siya?
Mo-combine man siya sa metal, sir. I mean, naman siya metallic na kon.
Na siya metallic nga compounds or
Yes, sir.
So sulfuric acid is a very harmful and should not be consumed. Its corrosive property is used to cleaning toilet bowls and drains. It can corrode our skin and make a hole in our ano man to, skin and make a hole in our hands. So should be handled with utmost care. So it is a commonly used for automobile battery. So next class, this one, milk. Is it an acid or a base?
Acid,
Acid, sir.
So it is
lactic acid,
Acid.
the pH milk. The pH of milk is from range from 6.7 to 16, which form to be acidic, making it slightly below neutral and therefore acidic forming. The exception is raw milk, which may be more alkalizing than pasteurized milk. So some non-dairy milks are also acid forming while the others are base. The next class, kani shampoo. Is it an acid or a base?
a base,
Base.
Base.
So klaro na kayo, no? So
Base.
isang texture pa lang na siya soapy
slippery nga
texture
texture.
and not
Danlog.
danlog. So they contain sodium salt of carboxylic acid. They are however made of carboxylic acid and sodium hydroxide. The next, our last picture. It, it is an acid or a base?
Base. Base. Base.
Base ba?
A ba- ah,
Nganong base ka siya? So you're under
Slippery man siya, sir.
slippery. So
Danlog.
it is not. So ang kuan nakadepende siya sa kadugayon sa egg. So but most of the egg white are acid daw. So while whole eggs are relatively pH neutral, egg white is one of the few products that is not naturally alkaline and with an initial pH value that can below as 7.6 at the time of lay, but with increasing alkalinity as the egg ages can be reached pH from 9.2. So if bago pa siya gi-lay, acidic pa daw siya. But from time to time, mahimo na siyang base. So now you already know the properties of acid and base. I want you to answer our quiz using quizzes that I made. So the link will be provided in our chat box. So nakasabot ra mo klase to ang koan discussion.
Yes, sir.
How sure you are? So any question about our discussion this morning? May question pangutana?
Think none, sir.
Answer.
Okay, none. So I will share to you the link of our quiz using the quiz. Nakadula na mo quizzes, guys.
Yes, sir.
Yes, sir.
Sir.
So wait for a while klasa, magkuhaon sa nako ang kuan. Magkuha ako sa link ha. Ano naman to siya So in this quiz, I will give you 6 minutes to answer it. So each question is 1 point tapos each question na po siya tag 10 seconds. So kaya ra guys, class, if 6 minutes, 30 items to siya. Kaya ra ninyo?
Unsay pa
Yeah,
mga ito,
sir.
sir?
Please click the link that I have shared to you in our chat box. Tapos, I will give you 6 minutes to answer it. So each question is 10 seconds. So, kaya ra class. Makaya ra ninyo?
Kakayanin, sir.
Kayahon.
So, I will give you 6 minutes to answer it. So, your time start now. So, Dapat sa 9:26 nakabalik na mo no. Naana mo diri.
Excuse me, sir.
Sige go on nahiyan.
Pwede mangutana unsay buhaton kay nawala kong signal.
Sige,
Karon pa ko
sense na ko.
kabalik.
So all you need to do is to answer our evaluation this morning using the link that I've shared to you in our chat box. Kita na nahiyan ang link.
Okay, sir. Yes, sir. Okay, thank you.
So I will give you 6 minutes in answering that. Tapos after 6 minutes, balik mo diri ha. Two minutes more class. The time is up, class. So kato mga nag-answer pa, please answer na lang kay lisod pud og putlo nato. So for your assignment this morning, please answer the experimentary laboratory worksheet that has been posted in our Google Classroom. So, is that clear, class? Kasabot ra mo, class? O busy pa mo nag-answer? Busy pa din na sila. Hmm? Wala. So, answerin na lang ninyo na guys, class, within this day. So, dapat within this day, mahuman ninyo na. So, for your assignment, please answer na lang sa katong laboratory experiment nato. Nag-send na ko sa kuan. Sa ato ang Google Classroom. Is that okay, class?
Okay, sir. Then sa Google Classroom, pod i-send ang amo
Yes, yan. So, sa Google
Okay,
Classroom
okay.
rapod. So, thank you for your cooperation and participation. So, esa mag-out na kanapay kuan discussion pod si ma'am ninyo. So, thank you, class. So, before we leave, ay, di pa mo ka-leave, no? Can you open your camera for uh, documentation, tutorials of this demonstration class? So, nalagi wala nag-open of cam. Kasi busy pa nag-answer, no? Sige, 1, 2, yan, sa iba nila. Sige, 1, 2, 3, smile. So, thank you. Okay na, ma'am. Nauman na, ma'am.
Okay, thank you, Sir Bin Laden. Okay, thank you, pod class, for participating. So, before the you will, class, you will answer the evaluation for Sir Bin Laden. Then also the assignment, the laboratory, you pass it. Sir Bin Laden will check them. Okay, and also, okay, you have 15 minutes break. Pwede sa mumuhawa kay magklase ko. Mag-CR sa ako, class. Bye-bye.
Pwede na muhawa.
Okay, ma'am. Pwede na daw.
Okay, sige ka mag-quiz pod.
So, katong, sa wala naka-answer, answerin lang ninyo itong kuan.
Wala pa tanaw man.
Pwede na mag-out, ma'am.
Pwede na.
Yes, pero balik lang 9, kito 9:50. Ay, 10:50 na yun po. 9:50.
9:50, ma'am.
Ah,
Okay, ma'am. Thank you, ma'am.
sige, balik ka mo kay mag-prepare po pod ko.
Napa di ang ibalikan.
Magtagadra ko.
Thank you, Ma'am
Now,
Equilibria.
agad.
Bye.
Bye, ma'am.
Ewe? Okay, hello. All right, let's
Hi,
start.
ma'am.
Okay,
Hi,
ma'am.
ma'am.
Okay. So here, okay, let's answer this one. Okay. Now again, how do we predict the direction of the reaction?
Unsa to, ma'am?
How do we predict reaction direction?
Nag-use og kuan ma'am reaction quotient ma'am. Compare sa KW.
Uh, okay. Yes, yes. All right. So here in predicting, okay, that's good. That's it also. But by just looking also here for the weaker or a strong one, then we can predict the reaction. So if we have this one, okay, letter A. Now H2PO4, okay, so we have this reaction. It reacts with an H3. Okay. Then, ballpen B. Okay. Okay. All right. Now to predict the reaction, man. Taxi si uncle. Kapalo. Sa sa mukha oy. Tapi nagkuhan pa ko. Okay. Sorry. All right, now this one to predict the reaction of the conjugate acid base pairs. So we will determine or we will look at the relative strength of each of them. So we have the stronger the species, the more preponderant its conjugate. Okay. Now, basta the stronger one will have the force. So it means that if the reactant has stronger base, stronger acid, then the reaction will favor to the formation of the product. So the direction will be to the right. And that is because also the Kc there will be greater than 1. So now, last time we had a question of this one, the H2O and the HS. So if we are going to look OH minus, okay, we will look that here if to determine if it's a strong one or a weak one. So we have that one. It says that it's a stronger base. So OH is a base. Okay, we know that. Now let's take a look to its position here. The OH. Okay, so H a strong one. Now going back to your to your acid, which is H2S. We have that one H2S. Okay, let's take a look H2S. So here is H2S. But here we says that it's a strong acid. Now it's a stronger one. It says it's a stronger one because it is comparing to the other. Now so it is being compared. It is being compared with the acid because this one H2S is just a conjugate, so it is being compared to its pair, this one which is water. Now when we look water is much weaker than our H2S. That's why we said here H2S is stronger than the pair, which is the H2O. Even if it belongs to the weaker one, but the comparison of it with H2O, H2S is stronger than your H2O. Okay. Okay. The same with now. Okay, so ano ra siya, i-compare nimo siya to say that it is a strong acid or a strong base. You're going to compare it with a pair. Now let's go back to letter A. We have H2PO4. Okay. Now we are let's identify if it is a strong, if it's stronger or weaker. Okay, let's compare this one with the conjugate acid. Okay. So we have that one H2PO4, which where is H2PO4? Okay, this one. Kita?
Yes, ma'am.
Okay. And
Yes,
then we
ma'am.
compare that one with NH4. NH4. Now, who is stronger? Kinsa strong nilang duha? Stronger. Katuna sa babaw. As we can see, as when we go up, the acid strength increases.
H2PO4.
Okay, H2PO4. So that's why we take it as stronger acid. Then we have also, so we label NH4 as weaker one. Now let's go back to NH3. NH3 add HPO4 to minus NH3. Okay, this one, and then we have the NH3. Now, who is stronger?
NH3. Ammonia.
Okay, yes, that's one. So that's why we label it as stronger base. Now, to predict the direction is the stronger one wins. So we have that one. So if it is strong, if the reactant is strong, meaning there are lots of reactant, so it favors product, therefore the reaction will proceed to the right. So that's why it will proceed to the right. Now in this case, in letter B, the stronger one is the product. So because of that, it to make it equilibrium, to restore the system, it will go to the left. Okay, that's why we have the direction is to the left. So, marag bali-bali or good gihapon class?
So in determining, ma'am, in determining the direction, ma'am, kay mag-base ta sa strong o sa weak base. Ay, sa,
Yeah. No, the both, the acid and the base.
sorry, ma'am.
Yes. So, that's it. Then, okay, so let's go. So, we have this one using molecular scenes to predict the net direction, okay, of an acid-base reaction. Okay, we have this problem. We have 0.1 molar solution of HX, which is the blue one. So you can see here, blue, the H, and the green one is the X. Okay. So definitely the HX is this one. How in letter A, in number 1 illustration, how many HX?
3, ma'am.
3. Okay, is it 3?
Ang HX ma'am kay kanang green ay blue.
Blue-green.
Blue.
3, ma'am.
Okay, 3. All right. So it has a pH of 2.88 if it is 0.10 molar. Now, a 0.10 molar of HX, it has a pH of 2.88. So it's, no, is it basic or acidic?
Acidic.
Okay, it's
Acidic.
very acidic.
Acidic.
Okay, now it's acidic. Got it. Okay. Now, and 0.10 molar of HY. So together with that, we have HY, which is blue and orange. So HY, again, a 0.10 molar of HY, it has a pH of 3.52. Okay, so of the two, which is more acidic?
Ang kwan ma'am, HX.
Okay. Now we know that acids and bases occur together. In reaction, there acts an acid and there acts a base. Now in this reaction, so let's write that one. If we have the HX, okay, when we pour that into water, so it will dissociate H2O. Okay, class, para mas simple sa inyo, you always write reaction. Okay, so if that's the case, what's the product? What's the product here? Let's write the reaction. Sorry. Because we react with Y. Okay, we have that one. Wait. Okay, so what will be the product? Okay, what will be the product? Who acts as a base and an acid here in this reactant? Again, the HX, okay, the HX has is more protonated, so it has proton in the form of H, so it will be the acid. Now, it will dissociate into water forming
H2O.
okay. All right. Now, in this case, it's with a Y. So we have that one. It will react with the Y, and then we have the X minus. Okay, we have that one. Now, so HX is in blue and green, and then HY is in blue and orange. So in this problem, we are asked of which scene best represents the equilibrium mixture after equimolar solution of HX and Y. So this time, we are going to determine the fraction here. So the fraction of HY, okay, we know that okay, we know that this one, KE is equal to product over reactant. So we have HY over X minus. And then we have the HX. No? Okay, the HX plus Y minus. But here in this problem, we are going to get only the fraction of your HY and HX. So HY over HX. So in number 1, okay, so the concentration of HY. Okay, what is the concentration of HY?
0.10 molar ma'am.
Okay, 0.10. But using this depiction, using this molecules, we have the HX. How many HX? 1, 2, 3.
3, ma'am.
3 over. What about HY? What about HY?
3, sir, ma'am.
Yes,
3.
ma'am.
3.
Three gyapon.
Okay. What about number 2?
4 ang HX.
HY?
2.
2.
2.
2.
2.
ba?
Now,
2.
this one, the HY over HX. HY over HX. We have HX is 2. HX is 1, 2, 3, 4.
3.
4.
4.
Four,
And
ma'am.
then we have
2. 2.
2.
Two.
3.
2.
Oh.
What about number 3?
Ang HY kay 4.
4 over 2, ma'am.
Okay. 4 over 2. So in this case, who has a higher Kc here?
Ang 3, ma'am.
Okay, so 3 because it's 2. So therefore, the SIN3 is consistent with the relative strength, acid strength. So it is stronger. Okay, in SIN3, it has the highest acid strength. Okay, so because there are more, there are more product. Okay, HY is higher than your HX. So if it is if it is a stronger acid, it means that it will dissociate completely. So in this case, di ba ang HY maumani siya ang HY is HY and the X minus is the product of the dissociation of your HX. Now, if we have more of this, it means that your HX is is a strong acid. Okay, because strong acids dissociates completely. So we have this one. We have a lot of product, the HY and the X minus. Now in this case, we have 3 in number 1 we have 3 over 3. So it means that it has the same strength. The base there is just equal. Okay, this one is just equal to this one. Then we have, if we but because in number 3 each y, okay, it has a more acid strength than your than in the depiction in number 1 in number 2. So that is why we have number 3 here is the answer. All right, so we have this one. We have finding Ka of the weak acid from the solution pH. Okay, so we have the weak acids. Okay. All right, so we have Cyril Jane. Please read the question or the problem. Acid.
Hello, ma'am. Excuse me, wala ko kadungog, ma'am. Bana kay sa amo agad na.
Basa daw ang problem.
Said, acetic acid. Ano na, wala.
Ana.
Okay, so we have. Okay, Cyril Jane.
Yes, ma'am.
Okay, please read.
Acetic acid or wait sa ma'am, ha, magpalayo ko kay bana.
Okay, so we have Emma.
Wait sa ma'am. Phenlacetic acid. I don't know how to read. Kanang C. Ma'am, di
Oh,
ko
inana,
kabalo.
go. C6.
C6H5CH2 COOH simplified her as HPEC builds up in the blood of persons with penic penic penico sunay penike ano pagbasa ni mo
Phenylketonuria.
Penicillitonuria, an inherited disorder that if untreated causes mental retardation and death. A study of the acid shows that the pH of 0.12 molar naman,
Hmm.
M
Yes.
a molar HPAC is 2.62. What is the Ka of phenalacetic acid?
Phenyl.
Uh, pen,
Phenyl.
pen,
Acetic.
Phenylacetic acid.
Okay, we have that acetic acid. So this one, C6H5, CH2COOH. Now, what have you observed? It has a carboxylic acid. Is it a strong one or is it a weak one? Basta na itong COOH. It is?
Weak, ma'am.
Okay, so it's a weak acid. Now, we know that weak acids do not dissociate completely. So, dili siya unsa nang dissociate ma-form mabuskag dayon
Badi o mabuskag.
okay, di siya ma-form dayon og two different ions. Okay, so because of that, in this problem, we will use the ice table, okay, for weak acids. Okay, now we have this one. Now, a study, okay, so the given there is we have a pH of 0.12, is pH of 2.62 for a 0.12 molar of your HPAC or phenylacetic acid. So we are asked of Ka. Okay. Now again, you will write the reaction. We have the HPAC. Okay. Plus, okay, when you put that into a solution, aqueous solution, so we have the water, then a reverse reaction of, we have, that's the product. Product is always class. Okay. Okay, so that's the product. Now we are asked of Ka. So how do we calculate Ka here? We have
H3O plus
H3O plus times PAC
HPAC.
PAC.
over
Okay.
HPAC
HPAC.
as water.
Okay.
Ay, wala day
HPAC.
water. Liquid day water.
Now,
Wala na yung water
we have
naman.
that one. Okay. So, we are asked of Ka here. We are asked of Ka. What is given? So we have
Ang
this,
pH,
no? Do we have, okay, do we have the value of your H3O plus ion? Is
wala
it
ma'am.
given?
No
Okay,
ma'am.
wala. What about the PAC?
Naa ma'am. Naa. Ay, wala din ma'am.
Okay, what about the HPAC?
Naa ma'am.
Okay, what is it?
62.
0.12.
0.12. Okay. Now, because of that, because this is a weak acid, so we will write the ice table. Okay. So how do we write the ice table? Okay. Okay. So ice table. Okay. And this one. Okay, delete natin yung water. So, what is the initial concentration of your HPAC?
0.12.
Wala gihatag ma'am.
It's given.
0.12.
Concentration here.
Mag equilibrium gano'n. Ay.
Like 0.12 molar. Okay, then this one is not given. So let's write 0, 0. And then for the dissociation, so the change, what will be the change? So let's write
Negative X.
Okay, minus X because it's the reactant. Then,
Plus X.
okay, plus X. Now, at equilibrium,
0.12 minus X.
then we have X, and then we have X. Now, because of this ice table, so let's write the Ka here. So let's represent H3O plus as X and the pack as X. So that will become, our Ka will become X times X times K. What is, okay, what is the H pack? It's
0.12.
0.12.
okay. So we have 0.12. Actually, it's 0.12 minus X at equilibrium. But we can assume or we can neglect X here. Para dili kita matasan sa ato ang formula. Now, we have that one, 0.12. Okay, so the value of Ka is given. What is it? Okay, wala dahil siya gihatag. Wala, class. Shucks.
Ang KA ma'am
Wala
kay
man ang KE. KE is not given.
1 times 10 to the negative 7.
1 times 10 to the negative 7. That's kW of water. Now,
14 man to ma'am. Negative 14.
oh, yes, negative 14.
Oh,
Now,
yes ma'am.
here, this one, K, it's not given, so we have that one, 0.12 Ke. Alright. What sa pala yung given?
Kuan man ma'am kanang ang Ka times Kb man to ma'am is equal to Kw then. Kung it times ang Kw kay 1 times 10 to the negative 14 then. Kung ang Ka kay 1 times 10 to the negative 7. Times sa Kb po.
Okay. We have the pH. pH. We have the pH. Now since we have the pH, we can get H3O plus. Okay, remember that pH, pH 2.62. Now we have that one pH. Formula of pH is negative
10
log.
to the
Okay, negative log of the concentration of H3O plus. Okay, di ba?
yes ma'am.
Now, so we have that one, 2 pH is already given, 2.62. Now, and what do we need here is the concentration of your hydronium ion because that's the X. Nana siya, di ba? Ito siyang represent as X here. Okay. So, unsa buhaton nato ani? We will use anti-log. Okay, we will use anti-log. So the anti-log of this one is we will have 10 raised to the negative of your pH. So we have 10 raised to negative 2.62. So we have that one H3O plus is equal to pila.
Ang water. Ay. Ang water ba?
Calculate. 10 raised to the negative 2. That's 2.0. 2.39
2.4, 2.5.
times 10 to the negative
3.
Okay. Nakuha ninyo sa calcu class, just 10, right? Mag-type mo drag 10, then raise to the negative 2.62. That's 2.3. 2.4 times 10 to the negative 3. Kuha?
Ma'am.
Okay. Now, if you have this problem, class, if you are given with pH, and then you are asked of the concentration of your hydronium ion, then you can just use anti-lag. This one is anti-lag. It's ano siya? It's anti of this logarithm. So we have that one. Anti-lag is 10 raised to the negative pH. Okay, so we have that one. The concentration of your H3O plus is 2.4 times 10 to the negative 3. Now, H3O plus is, ano, diba? Is your X. Okay, so we can write that one. So 2.4 times 10 raised to the negative 3. X times X.
X squared.
Okay, so let's
Squared.
square this one. So the square over
0.
0.12. So what will be Ka is equal to square. Square na nasa calcu divided by 0.12. 4 point. Ka is pila?
4.8 times 10 raised to the negative 5.
Okay, so that is your Ka. And that is what is asked. Okay. Okay, pwede na dito di mag-ice table, Sani. Okay, because we are, say again, all right, again ha, because we know the formula of Ka, Ka is asked. Ka is this one, H3O plus times Pa times the PAC over the reactant HPAC. Okay, that one. Now we have that one. Now, then we will, because we don't know the concentration of your H3O plus, your PAC, so, and then we are only given with this HPAC, the initial concentration, so we will use the ice table. Okay, we have that one at the initial is 0.12 molar. Then we have the 0, 0, okay, since not given, so we can write just 0. And then also we have the change is negative X, because this negative X is the dissociation, di ba mo dissociate man ni siya into H3O plus and into PAC. So ato lang siyang ginakuan as negative X, iyang dissociation, iyang pag pila ang concentration niya ni dissociate. So at equilibrium, kabalutang ang at equilibrium nabilin is your initial concentration minus dahil atong na-dissociate, minus atong nimbulag. Okay, minus atong nibulag. Now, because this is a weak acid, we know that the weak acid will not dissociate completely. Dili siya mahimong H3O plus and PAC tanan. Possible na apa na siya HPAC nga dako. Okay, gibutang lang niya gibutang. So, because this is a weak acid. Now, because it's a weak acid, we can neglect the value of X, ma-assume nato nga, gamay ra na siya, gamay ra ang ni-dissociate, gamay ra ang nahimo nga H3O plus, o gamay ra pong nahimo nga PAC, because it's a weak acid, dili siya completely mahimong H3O plus and PAC, na apay mahibilin nga HPAC. Now, because of that, we neglect that one also, because for our simplicity sa ato ang pag-calculate, kay di ba? When we write that one, in our equation, each pack will become 0.12 minus x. Now, if that's the case, so mugamit pa ta ng quadratic equation, no? So, we just neglect it because acetic acid, so makita na to nga. Ano siya? Gamay ra kay na siya. Negligible ra ihang dissociation. Now, then, after that one, okay, we have the x, and then the x here, that's at equilibrium. Then we have, okay, x times x, that x squared, and then we have 0.12. Now, we know that we are asked of Ka. So, matingala ka, Ka ako pangita, di mo applicable sa value sa x. Now, because we are given of your pH, we know that pH is equal to negative log of the concentration of the hydronium ion. So, we can get the concentration of your hydronium ion by anti-logging. So, we will use anti-log 10 to the negative pH. And then you will get the concentration of hydronium ion, that is 2.4 times 10 to the negative 3. So we can write 2.4 times 10 to the negative 3. Because at equilibrium, H3O plus and PAC are equal, so they are x and x. So we have x squared. So 2 to the negative 3 over 0.12 equal to 4.8 times 10 to the negative 5. Now, how can we be sure nga sakto ang ato ang gibuhat nga atong gineglect ang x basin day ma'am na din ay value ang x dira ma'am nya nagansi na ta pag divide ana gamay ni mong KE nakasakto ka ta. Now we can neglect the value the x here. Saman to. We can neglect this x, this one. Maneglect nato na siya when. Okay, we will check dayon the answer. We will check the answer. Okay, so we have we will use the fraction, the dissociation, percent dissociation. So we have that one. Percent dissociation is equal to na sure chud ka basin dili dito pwede neglect. Okay. Dissociation over the percent concentration of your initial times 100. So what is the HA dissociation dito? We have what is X? Pili value sa X class.
0.12.
X 0.12, that's the initial concentration of your H pack. X is
4. 2.4 NO.
2.4 NO raised to the negative 3.
2.4 times 10 to the negative 3 divided by H initial. So, katungo pa siya nag-dissociate bakla. So, pa na-break. Pilang concentration?
0.12.
Okay, 0.12 times 100% times 100. So, how much is that?
2.2. Tura.
Divided by 0.12. 0.02 times 100. Okay, so that's 2. That's 2%. Now, if your dissociation concentration is less than 5%, then you can be confident that neglecting X in your H pack is reasonable. If imo checking nimo is less than 5%. So we have that one, 2%. Now, if you find out that, oh, hala, it's 6% ang answer, dapat dili nimo siya i-neglect ang X, then, di nimo siya i-neglect, then use that one. You put an X there, then by that, ano na dayon, magka-problem din kakay. Ano, there's two unknown variables. So, dako na po din siyang math. So, that's it. You neglect X, but mostly the problems given are they neglect X because since this is also a weak acid, so the dissociation is very small, so it's negligible. Okay. Now that the one, so let's go to the next page. Okay, so we have this one. Propanoic acid. Okay, please read. Okay, Angel, Jana.
Ma'am?
Okay, read the problem.
Wait sa ma'am kay naglag akong cellphone dili maka-click. Propanoic acid. CH3, CH2, kani ma'am? COOH, which we simplify as PH, HPR, is an organic acid whose salts are used to retard mold growth in foods. What is the saan kita ni ma'am? What is the H3O plus of 0.10 HPR of Ka is equals to 1.3 extent.
Okay, Jana, go. Hydronium ion of 0.10 molar. Propanoic acid, HPR. Ka is pilang Ka?
1.3 times 10 raised to the power of -5.
Okay, that's okay. So, what is the problem? What is asked? Asked is?
Ang H3O+.
H3O plus.
H3O plus. Concentration. Okay, hydronium ion. So that's what is asked. Given. The given. Given is
molar.
Ila. 0.10 molar. Okay. Then also what else? Okay, HPR. Nana HPR. Propanoic acid. Ke is 1.3. Maklaro ra ako sulat. Ilisan og ballpen.
Hanap gamay ma'am.
Hanap.
Unsay color nindot day tanawan?
Red
Para mas red or green ana.
Red or green, okay. Oh, so we have that one, okay. So again, we will write the reaction, okay. So the reaction will be HPR, then in water it will dissociate. So pwede ang uban ginabutangan pag H2O, ang uban wala na. So we have that one. The product is
H3O
Hydronium plus PR minus.
Yeah, all right. Now it's Ka. Ka is equal to
hydronium times
H3O plus
PR minus
times PR
over
negative over
HPR.
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 Okay. Now, after that one, KE is given already know what is KE 1.3 times 10 to the
1.3
negative
times
5.
10 negative 5.
Asked is hydronium ion. Na po ni given na po. Okay. This one and this one is asked. Okay, let's make an ice table. Pag maayo na kay ka, pwede na makadi mag-ice table class. But using ice table, makita jud nimo siya. Mas maklaro nimo. Okay, we have that one, H3O plus, and then we have the PR minus ice. What is HPR initial?
0.10.
What about
0.10.
hydronium ion?
0.
X, ma'am, not given.
Okay, 0. 0. PR also 0. Now, okay, for the change,
Minus X.
then equilibrium, I hear sa plus X
Positive X.
X.
plus
Plus
X. Then
0.10 minus X.
0.10 minus X.
X and then X. All right. So we can write KE is equal to pila.
X squared over 0.10 minus X.
Okay, 0.10 minus
Minus
X.
X.
Now, we will neglect X. Okay. So, we will neglect X ha. Okay. So, we have KE. So, X squared. Now, we have the value of KA. KA is 1.3 times 10 to the negative 5 is equal to X squared over 0.10. So, X squared is equal to walang X squared.
0.10 times
Pila? X squared is 1.3. Sakto ba? Okay. Sakto. X squared. Okay, plus ninyo class. 1.3. Nagkalkyo mo?
Yes, ma'am.
Okay. O, pila. Sakto. Krista. Then, to eliminate X, to eliminate square, well, square root. Square root. So, X is equal to pila. Krisa. Pila man. No. Nagkalkyo mo? 1.3 times 10 to the negative 10. Square root of that is 1.14
1.14 times 10 to the power of 3. Negative 3.
Okay, so this will be your X. X is equal to H3O plus. So that's the concentration of your H3O plus. And then that is equal to the PR minus. No? So, nakuha na tong answer. What's the concentration of H3O plus?
0.14.
What's 0.14? Concentration of H3O plus is
1.14 times 10 to the
negative
Negative
3. What about the concentration of PR minus?
same ra, ma'am.
Same ra, ma'am.
Okay, because it's represented as X. Now, let's check if, sakto ba ito nga gineglect natong X here, di ba? 0.10 minus X man unta ni. Na, gineglect nato. Let's check. Para maka-sure to check ta. So, we have, pila to value of X? We have percent
1.
dissociation. Is equal to dissociation over initial times 100. So we have 1.14 times 10 to the negative, pila to? 3 over initial.
0.10.
0.10.
Okay. So pila percent? Percent pila is equal to pila 0.10 1.14 times 10 to the negative 3 divided by 0.10 times 100, that is 1.14%. Okay, is it reasonable nga gikuan na to gineglect? Okay. Yes, because it's less than 5%. Okay, so let's go here. Naman siya. All right. Now, kato ganina class is like HPAC. The HPAC, how many? Okay. Then HPR. Okay. How many ionizable protons here in HPAC and HPR? How many ang pwede class? When we say ionize, mahimo siyang ion in under the water condition. Mahimong ion, pila ka buok? Mahimong protons here. In HPR, pila ka buok mahimong protons? Duha. Duha? Duha ngali ka ion, pero ang ion, di ba, positive, negative. When we say proton, katong positive, pila ka buok? Pila ka HPR, mahimong? How many atoms of HPR? How many atoms of H, hydronium ion?
3.
Pila? Pila day ka H class? Only one. So it means that it is monoprotic. Monoprotic means only one ionizable protons. So isa ra ka H. Then what about the H pack? Is it monoprotic? Is it monoprotic? H pack.
Yes, ma'am.
Yes,
It's
ma'am.
monoprotic. Okay. We have one rabi siya diri class 1 and then 1. Then when it dissociate, mahimo siyang 1 proton and then we have one another one ion, negative ion. Okay, we have this one. We have polyprotic acids, acids with more than one ionizable proton. So if we have H3PO4, how many ionizable protons here? In number 1.
2.
Sa H,
5.
ma'am.
3.
3. 3.
5. Ay.
5.
3.
Di ba class, ang proton is represented with H? Now, the number of protons is equal to the number of ionizable one. Okay, di ba ang mahimong kuan? Alright, we have 3. So first reaction is mahimo siyang this here. H3O H3PO4. H3PO4 plus water. So reaction. Plus
H2PO4 minus.
Then it has a value of Ka 1. Now, because it's underwater, so mo dissociate pa ni, di ba? H2PO4. Okay, so H2PO4 plus H2O. Okay, product. What's the product?
One, ma'am. H hydronium plus HPO4 minus.
Now, ma-ionize pa siya. Ma-dissociate pang H.
Yes, ma'am.
Okay, so this will have your Ka2. And then we have HPO4 plus H2O. Okay, product.
Hydronium plus PO4
Okay,
minus.
Emma, what's the product?
Kuan, ma'am. H ano? H3O H3O plus kuan. Wait.
So, ang wabilin kay plus
PO4 minus.
H2O o sa ba?
PO4.
Emma.
PO4, ma'am.
Ha?
Dili.
PO4 minus.
Okay. Now, when it's dissociation, gali Emma and class, ino siya when we have the compound then plus underwater, so it will dissociate the first proton. We have the H3O plus na dayon imo ma-form kay di ba? Okay, and then we are left ang mabilin kay di ba H3 man ni siya diri. Then ang isa ka H ni balhin sa H2O. Pila na lang ka H ang mabilin? We will be left
H2.
with H2PO4. Now, because this has still proton, ano siya, it still can act as acid in water. So, mahimo mo dissociate na po na siya, H2PO4. Underwater, it will become H3O plus, pilay mabilin diri class. Nibalhin ang isa, ka H. You will be left with
Only one H.
only one H, HPO4 minus. Then, again, you put the charges class, the plus and the minus because, ano siya, ionization man ni siya nga reaction. Then, we have also this one, HPO4. Mo-dissociate na po ni siya, kay acidic pa man siya, kay it has H pa man. Then, what will
Wala na yan.
happen? Okay? So H2O, then H3O plus, then PO4 minus. Now, polyprotic acids has many Ka. Now, if we have three ionizable protons, then we will have 3 Ka there. Now we have that one, a K like here. We have H3PO4. Name mo siyang H2PO4. And then this one, the Ka1 is the value is this one. And this one, Ka2 and Ka3. Now, the Ka values decreases. Ka1 is greater than Ka2, greater than Ka3. Why is that? Because nag-dissociate naman class, nag-dissociate siya, then ang mabili na lang pod mo ay mo dissociate na pod, then the value of there magkagamay dayon siya. Kaya nagkagamay na lang man ang dissociation of H3O+. Okay, naro. Alright, we have that one Ka decreases. Okay, so we have this one. Okay, 0.15. Solution of acid blue and green is 33% dissociated, which seen best represent a sample of the solution after it is diluted with water. Now, what will happen? Okay, what will happen to your dissociation? Now, if you have your HA, okay, HA plus H2O, then pilay product ani class? What's your product? Plus, always na na siya. Okay, that's the product. Now, if dilute, unsa gali ng dilute? It means if we have dilute, it means more water.
Bungkak.
Ha? Lasaw. More water. Now, if we increase, if we dilute your solution, so meaning there will be more water, there will be more molecules in which your HA will react to. Now, kung mas daghan na noon imong water, daghan na imong concentration sa water, then it means daghan og siyag ma-reactan imuhang HA, therefore producing more H3O plus ions. Okay, so ano siya reaction, mas mo favor siya in the formation of H3O plus kay daghan man siya ma-react na water. Okay, we have that one. Now, if we have 0.15 molar solution of acid, the blue and green, okay, blue-green. Is dissociated, which seen best represent a sample of the solution after it is diluted with water. So, percent dissociation is equal to pinagal ito?
Equals H3O.
Okay, H3O plus. Kato man yung nag-dissociate mo. Kato ganina, we are just writing it like this. Okay, percent dissociation over initial. So, to be specific here, we will write it like this. Then, also the initial concentration. Initials are?
HA.
Okay, HA. Plus
H3O plus, ma'am.
Okay, we have that one. Now times 100. Okay, in letter number illustration 1, what is percent dissociation? How many H3O plus?
4.
4.
Okay,
Four.
4 over HA.
5.
5. 5.
4. 4.
5.
1, 2, 3. Oh, 5.
5, ma'am.
5.
Plus,
4, ma'am.
4.
okay, percent times 100. So, percent dissociation is 4 divided by 9
44.
times 100, 44. Okay,
Percent.
44%.
44.44%. Okay, what about number 2? Pila yung percent dissociation?
2.
2. 1, 2.
2 over
2 over 1, 2, 3, 4, 5, 6, 7.
7.
2 over
7 plus
7
Ta-
plus 2.
plus 2.
Plus
times
2.
100. Okay, pila?
22%.
22%, ma'am.
22?
Or
Okay,
22.8.
what about number 3?
3.
Ang
3
acidic
over
over 1, 2, 3, 4, 5, 6 plus 3.
6 plus 3 times
What's that?
100.
'Ila?
33%.
30, 30,
Okay, 33. Okay, 33%. Now, which represents uh, dilute solution? Which represents dilute solution?
Number 1.
man.
Number
1,
1. Okay, again, when we have a dilute solution, there will be higher
amount of
dissociation. Okay. So, higher imuhang percent dissociation if you have a dilute solution. So, the highest percent dissociation here is 0.44. So, number 1 is pinaka-dilute. Okay, so we have that one. Okay, so we have Ka values for some polyprotic acids. Okay, as you can see, when Ka, kung magkadaghan ang Ka, then it will decrease. So we have 5.4 is greater than 5.34 times 10 to negative 5. Ka1 is greater than Ka2. So just observe. Okay. Now again, when we say polyprotic, those are the ionizable protons. If we have oxalic acid, this one, your oxalic acid looks like this. It has a structure of this one. Now, the H plus, okay, this one, they will become ionizable protons. So they will ionize. So if we have H2C2O4, we have a diprotic. We have a diprotic acid. Okay. Now, if we have only one monoprotic, if we have 3 triprotic, so they are called polyprotic. So daghan ang mga ionizable protons. Okay, if we have carbonic acids, Okay, classify carbonic acids into iodizable protons. It is what? Carbonic acid. Asang carbonic acid? Carbonic acid is
4.5 times 10 H2CO3.
okay. What is it? It is monopoly.
Die.
Okay, it's diprotic. Okay, it has two ionizable protons. Okay, we have here calculating equilibrium concentrations for a polyprotic acids. Okay, for polyprotic acids. So we have this one, ascorbic acid. Okay, please read Krisa.
Ascorbic acid H26C6 H6O6 H2ASC for this problem, known as vitamin C, is a diprotic acid. Ka1 equals 1.0 times 10 raised to negative 5 and Ka2 equals 5 times 10 raised to negative 12 found in citrus fruit. Calculate the H2ASC HASC raised negative A, A, ASC raised to 2 negative and the pH of 0.8
Ay,
molar
daghana on. Okay, daghana
HASC.
calculate. All right, so what is asked? Concentration of this one, ASC. This one, Pajud. This one, and pH of, okay, pH is given. Oh, and pH. Okay, we have four. We are asked of four unknowns. Okay, we have H2, ASC. Okay. Now, but okay, so let's not write anymore. Let's write the equation. Okay, let's write the ionization. So we have, okay, when we put that into water, it will ionize into product.
H4 AH3O plus
H,
A
ABC
C
negative.
minus.
okay, what's the Ka? This is Ka. Ka is Ka
1
is
1.10 1.0
1
times 10 raised to negative 5
5.
10 raised to negative 5.
okay. Now what about, okay. Now after this one, since this is diprotic, so we will assume that we have two equations here. Now, okay, this one will be your, okay, reactant na po diri. HASC because it will still dissociate plus H2O, then the product is
H3O plus A S
AN
C minus.
S
Ka is equal to K2.
1
Given
5.
5 times
5 times
10
10 raised to the
raised
power
to
of
negative
negative 12.
Negative 12.
negative 12. Okay, that's it. Now, we know here, if we write Ka here, Ke is equal to, ato i-tagsa-tagsa, H3O plus times HASC
SC minus.
over Diba? Equal, ano man yung equation? Then Ka2 is equal to product of a reactant class.
H3O plus concentration of ASC minus over
Right.
SC negative.
Negative.
Agay.
Okay. All right. Now we are given with that. So Ka is given. Then we are asked na dayon of this one. Unsa pa yung given class? Unsa pa yung given?
itong pH.
pH is not
of
given. pH is asked.
kaning
Ay, ang molar.
Concentration. Concentration. Okay, so let's make an ice table. Concentration we're given. So we have the equation H2ASC.
Na may masa kuan.
Then we
Gawin
have
MJ.
H3O plus HASC minus the ice table. Last na dyan ni class nga ikuan. 0.050 no molar. The change.
Oh.
minus X.
Minus X. Then
0
minus X.
0.6.
Then the initial.
0. Positive X,
0,
positive
X, positive X, and X.
So Ka is equal to
X squared
0.
0.050.
Okay. We will neglect X. We will neglect X. So X square. Pila gayang Ka? Ka1 1.0.
0.0 times.
Okay. Now, class, sige, go. Calculate na din mo. Pila? Pila? Calculator.
7.1. Ay, sakto ba ni?
7.1.
7. Ang i-times ma'am no, ang 1.0 times 10 negative
Oh,
5.
X squared pa kung gipangayo class. X squared pa. Pila man eh. Calcul. 1.0 times 10 to the negative 5 times 0.050. Calculate din class. That is 5.0 to the negative 7. So, yeah, we only need X, so we will square root. Square root. Okay, square root of your answer. That is 7.07 times 10 to the negative 4. Okay, that is X. Now we know that X is also equal to H3O plus, then equal to the concentration of HASC minus. So if I ask you what is the concentration of H3O plus,
7.07
what
times
about
100.
the concentration of HASC minus?
Same ra sa concentration
Okay,
sa
same
H3.
ra. Now, okay, so nakuha na nato ni no. Nakuha na nato ni concentration. Nakuha na po din nato ang mao pa. Okay. And mauraw na ko ano to. Kanina naman ni given naman ni. Okay, the pH. How do we calculate pH? pH is kung ano tong pH? pH. Okay. pH. What's the formula sa pH? Negative log of? Okay. Negative log of concentration sa H3O plus.
7.07 times 10 raised to the power of
Pila?
4.
Negative 4. Okay. So, what's the pH? pH is
3.15.
3.15. Okay. Then, alright, nakuha na natong pH. Yes. At sa wala? This one. No? That one. Asa man nato ni makuha nga concentration? Kung atong i-ionize atong HASC. So, we will go to the next ice table. So, we have another reaction. Magsugod ta sa kani, di ba? Mo-dissociate pa man ni. Okay.
yes, ma'am.
Yes. So, we will write that one. HASC plus H2O. That will become ASC minus plus H3O plus. Okay. So, makuha na nato nino. Kanima itong gikuha. Okay. Initial concentration, ani. Pili concentration, ani.
0.05 ba to?
Oh, concentration na sa H2ASC.
7.
Let's go back.
7.07
7.07 times
10
10
raised
raised
to
to
the
the
negative
power
4.
of 7.
Okay, sige. Wa ko katimaan. 7.07 times 10 to
Times
the?
10. Negative
Negative
4.
4.
Okay, initial of ASC.
0.
0.
Change.
Negative X.
Negative X.
Positive X and positive X.
Okay. Equilibrium.
7.07 times 10 raised to negative 4 minus X.
Minus
X.
X and X.
Ka. K2 is equal to, nato yung value ani, pila to? Given siya.
5 times 10 raised to the
Negative to?
negative 12, ma'am.
Negative 12.
Negative 12. Okay. Ka also in the formula it will become anak man di ba?
H3O.
HASC minus. Minus na ni siya class. Okay, that is equal to X. X square, correct? Correct ba X square?
Ma'am, yes, ma'am.
Yes, over
7.07 times 10 raised to the negative
raised to the negative 4.
4.
Okay, should we include X? Neglect sa nato class. Neglect. Okay, so calcio. The Ke is 5 times 10 to the negative 12. So x is equal to, x squared is equal to, pila class? Calcio class. Amo mo na ta. Pila ni? Okay, equals. Pila.
3.85 times 10 raised to the power of negative 15.
3.85? Kinsa isa? 3.55 lagi ako oh. Lahi daw. Pizza pa isa.
Paan lagi ako?
3.53 ako, ma'am.
Oh, para
Dili
ta.
din, ma'am.
3.53. 3.53 times 10 to the
10
negative
to raise 5, ma'am.
15. 5 ra imo kuan?
Yes.
Balik ka daw na Christian. 15. Kinsay 15 para sa ako? 5 ra? Negative 12 ang isa. Negative 14.
Same to, ma'am, sa answer.
Same. Okay. So, after this one, sakto na? What's the next step? Eliminate square. We will?
Square root.
Okay. So, what's the answer? So, x is equal to square root of ons, that is 5.95 times 10.
Negative 2, 5.
Okay. Take sayo. Balik class. Sayo pa jud. Now, naa naman tayo value sa H3O+. The value of
Yes, ma'am.
H3O+ is this one.
Kuan, 7.07.
7.
Aha. 7.07. Kinsa nakabantay? Okay, this one is the initial 7.07. 7.07 times 10 to the negative 4. Okay, after that one, that at equilibrium, it will become, at equilibrium, that is
7.07 times 10 raised to negative 4 plus x. Oh, plus
ay
Negative
negative.
plus.
Ma'am.
Plus X,
Okay,
ma'am.
plus x. So, that thing is, after that one, dili din siya dili. Okay, so we will neglect x. So we will have, what's the numerator? ASC is x times
X, ma'am.
Kuan,
Times
7.07
7.07 times 10 raised to the
to
power of
negative
negative
4.
4.
Okay, then after that one, cancel. Okay. Di ba?
Yes, ma'am. Kay same naman silang value.
Can we cancel that one?
Yes, ma'am.
Yes, ma'am. Kay equals to 0 naman, ma'am.
Okay. So x is equal to
Kung sa
5
KE,
times 10 raised to the power of negative 12.
Okay, so that's it. Charang! Ah, okay, so that is X. Now, what's the concentration of ASCE? IC minus ASC minus equals
5 times 10 raised to the power of negative 12.
okay. So nakuha na nato kompleto na. All right. So nakuha na pud nato. So that's it. Okay. So question. So your concentration, okay, atong ikuan class. Let's summarize. So the concentration of H2 ASC, concentration of HASC minus, concentration of SC minus, then the pH is equal to, okay, concentration of this one. This one. Is
1
0.
point, 0 point
0.050. 0.050 because at equilibrium we neglect, di ba, ang X because it's very small. Then we have HASC, pila to? Pila tong HASC? 7. Point, di ba?
10.07 times
7.07
negative
times
4.
10 is equal 4.
Then the pH is 3.15, timani. pH
3.15.
is 3.15, then 7.007.
0.07
7 times 10 to
times
the
10
negative 4. What about
4.
ASC minus?
5
5
times
point
10 raised to the negative 12.
5.0 times 10 is the
Okay, molar. Molar in molar. Okay, so yay, we are done. Now, okay, so next meeting, okay, we will go to KB. So last meeting na nato karong ano, then we will have an exam dayon. Okay. So that one KB. All right. So see you on Monday. That's all for today. Happy weekend.
Excuse me, ma'am.
Yes.
Di happy among weekend, ma'am.
Why? Nga
Pwede
naman.
naman sa record ba kayo mag-review?
Oh, ang record ani ako na pong i-upload.
Thank you,
Okay,
ma'am.
ma'am.
Thank you, ma'am. Thank you, ma'am.
Hapit na jud ta, gamay na lang, di ba? Gamay na lang. Dali ra kay siya. Dali na lang KB and KB na din ta. So that's for acid or base? Sa base, no? So
Base.
KB, okay. So how do we calculate KB? It's just the same with KA. Okay. Just that we will be dealing with letter B, and then instead of H, we will have the OH. Okay. So thank you so much everyone for attending. Okay, God bless you all. Happy weekend. Bahalag dili happy ang weekend na. Parehas ta. Daghan pa ko. Ay. Sige, laban na lang
Dagan
tayo.
Ano
pagkulang.
naman, ma'am?
Ha? Sige, kulang. Naapit siya class. Oh, napapod ko pambuhatan class. Napa ko'y conference. Ano, pa ko naman sa akong kuan. PowerPoint. So, that's all. Thank you so much. God bless you.
Bye,
Amping
ma'am.
Bye, ma'am.
Bye-bye.
Bye, ma'am.
Bye.
Hi, ma'am. Thank you.
Ma'am. God bless you, ma'am.
Tulog-tulog ra ko ba nani?
Si Ariel, sige nagkatulog. Yeah na.
Katulog agad.
Relax lang, God. Susto man.
Wag, grabe.
Record ka pa ni panguli na mo.
Daghan kag activity ay.
Talogan na lang ang activity.
Yun ay, bye.